Hello and welcome to the Bradley Lectures podcast. I'm your host, Jackson Wolford. In spring and summer, we often take special note of new life and natural beauty. However, for decades, this appreciation has been tempered by warnings of impermanence. Our environment, its species, and the very climate in which we live all remain under conditions of duress. In this month's lecture, we will hear from Pulitzer Prize winner Edward Wilson, perhaps the most influential biologist of the last 50 years, and an early pioneer of the study of sociobiology. His lecture, delivered in 2001, addresses the dangers facing the world's species, strategies for slowing their decline, and the importance of preserving our natural capital.
Our relation to the rest of life can be put in a nutshell. In the past several decades, scientists have found the biosphere to be richer in diversity than ever before conceived. That biodiversity, which took over 3 billion years to evolve, is being eroded at an accelerating rate by human activity. Loss will inflict a heavy price in wealth, security, and spirit. Allow me further the proposition that the bottom line in global economics is different from that generally assumed by our leading economists and public philosophers. They've ignored mostly the numbers that count. Consider the following. With the world population past 6 billion, on its way to 8 billion or more by mid-century, probably leveling off around 9 to 10, before mercifully peaking at that level and starting to descend, per capita fresh water and arable land are dropping, they have been for 40 years, to levels that resource experts say globally are very risky. The key statistic is the ecological footprint, which is the average amount of productive land and coastal marine environment appropriated by each person, not in a single block, for example, around you, where you might live in, say, Maryland or D.C., but in bits and pieces from around the world needed for food and water, housing, energy, transport, commerce, and waste management. Each person, for example, draws down on a little bit of Costa Rica for coffee, a little bit of Saudi Arabia for oil, and so on. In the developing world, with 5 billion of Earth's 6 billion people, the ecological footprint is about 2.5 acres. In the United States, it's 10 times that much, about 24 acres. For every person in the world to reach present American levels of consumption with existing technology would require 4 more planet Earths. 4 more planet Earths to make a United States of Earth. The people of the developing country may never want to attain our level of profligacy, but in just trying to achieve a decent standard of living, they've joined the industrial world in converting the last of the natural environments and reducing a large part of the planet's fauna and flora to endangered status or final extinction. At the same time, our species has become a geophysical force, as I'm sure you're all aware. We've driven atmospheric carbon dioxide to the highest levels in at least 200,000 years, unbalanced the nitrogen cycle, thinned the protective ozone layer of the atmosphere, and triggered global warming that will ultimately be bad news everywhere. Our destruction of the natural environment began a long time ago in what can be described as a mistake in capital investment. Humanity, having appropriated the Earth's natural resources during the Neolithic Revolution, starting about 10,000 years before the present, chose to annuitize the resources with a short-term maturity reached by progressively increasing payout. In other words, we proceeded to gulp down our capital, our natural capital, and faster, like a wastrel heir to a great fortune he did not earn. At the time, it seemed a wise decision, and viewed in the short term, it still does. After all, the result is rising per capita production and consumption, markets awash in consumer products and grain, and a surplus of optimistic economists monitoring GNPs and competitive indexes. But there is a problem. The key elements of natural capital, that is, earth, arable land, groundwater, forests, marine fisheries, and petroleum, the capital that underlies the market economy are finite and not subject to proportionate capital growth. They are furthermore being decapitalized by overharvesting and habitat destruction. Therefore, with population and consumption continuing to increase up and up at exponential rate, the per capita amounts of resources left to be harvested are falling and destined to do so at a faster and faster pace in the future. The long-term prospects are not promising. Humanity awakened at last to the realities of the natural economy, which is, to repeat, underlie the capital economy, has begun an earnest search for alternative sources of materials and energy. Altogether, I will be so bold as to suggest, the 21st century is destined to be the century of the environment. It will be the time that we will put our house in order and settle down before we wreck the planet. This doesn't stop us from going to Mars. It doesn't stop us to create miracles of high tech, to unite humanity, to do wonders in biomedical research, none of those things. But underlying all of this is the great theme of settling down before we wreck this planet. The immediate future, I would like to suggest, is usefully conceived as a bottleneck. Science and technology, combined with a lack of self-understanding and Paleolithic obstinacy that led to our ruinous environmental practices, have brought us to where we are today. Now science and technology, combined with foresight and moral courage, both based upon a more enlightened ethic about the planet, must see us through the bottleneck and out, one hopes, by the end of the century. There are two collateral effects of the bottleneck phenomenon worth keeping in mind. The first is that the rich go richer and the poor grow poorer. The income difference between the fifth of the world's population in the wealthiest countries and the fifth in the poorest countries was 30 to 1 in 1960, 60 to 1 in 1990, and it's now 74 to 1. 800 million people remain in what the United Nations classifies as absolute poverty. No sanitation, no clean water, rampant disease, and periodic starvation. Even if the income differential is dismissed as a humanitarian issue, and even if we say, as many economists do, that it's just a matter of time of all ships rising to bring those in greatest distress to a safe harbor, it should still be considered a security issue even on the short term, because it's the setting, as you well know, in this institute, for resentment and fanaticism and the arrival of heaven-bent suicide bombers, some of whom, and probably relatively soon, will be armed with nuclear and biological weapons. Now, the second collateral effect, and the one to get down to business, that I've personally paid a great deal of attention to, and most earnestly want to call to your attention, is the accelerating destruction of the natural environment, leading to the mass extinction of ecosystems and species. The damage already done can't be repaired with any period of time that has meaning for the human mind. The more it's allowed to grow, the more future generations will suffer for it in ways that are both well understood and still unimagined. The radical reduction of the world's biodiversity now underway is the folly our descendants will least likely forgive us. So let me review, to that end, making that point, some of the basic facts concerning biodiversity, or biological diversity for short. First, what is biodiversity? Well, it's all of the heritable variety of life. It's the creation, if you will, and biologists divided into three great organizational levels, and they are illustrated, two of them are illustrated here. Ecosystems comprising shallow marine water environments is illustrated, mangrove, rainforest, savanna, and so on, ecosystems. And then the species that compose the ecosystem that are variously relatively gigantic, like butterflies, and ultra-microscopic, like the archaeans and bacteria. And thence the third level of biodiversity that biologists slice through in making sequential cause and effect analyses of diversity of life are the genes. This is a summary of the numbers of species known from the major groups of plants and animals, known and given a scientific name. This is slightly out of date. The current figure of species of plants, animals, and microorganisms named, given a scientific name, like we are Homo sapiens, lies somewhere between 1.5 and 1.7 million. We don't know the exact number because we still haven't done a complete census, and we are not all that sure about, even to the nearest order of magnitude, how many species are out there. This fall, I'm going to host at Harvard the first summit conference of the various organizations around the world, such as those sponsored by the Nature Conservancy and the OECD, United Nations, and so on, that are beginning to push toward a total biodiversity survey at the species level around the world. We have the technology to do that now and speed it up while speeding it up by an order of magnitude. That's one of the things that high tech in the communication industry has made possible, is that basic form of research. I hope that this will develop into the environmental equivalent of the Human Genome Project, so that we'll have a solid foundation on which to make our estimates of the numbers of species and, more precisely, the status of them in different parts of the world. The dominant group with reference to number of species known at the present time are the insects, and in the photosynthetic organisms, the flowering plants. Here is distribution of the known species at the present time represented as a speciescape, and the organism, representative organism, made a size proportionate to the number of species known to science. So we have a gigantic beetle looming like a Goodyear blimp, representing all the 750,000 species of insects known, above a tiny elephant, which those of you on the front row can see. That represents our group of mammals with a little more than 4,000 species. And the little elephant is lost under these giant mushrooms there, representing the 60,000 species of fungi. And we are fairly sure that there are more than 1.5 million species of fungi out there. In other words, to bring this quickly together, we know a little more than 1.5 million species, but of organisms of all kinds, but we think that the true number out there is somewhere between 10 million and 100 million or more. The unknown, the black hole of biodiversity, are the bacteria. There are a little more than 4,000 species known to science. They're extremely difficult to distinguish, to name, and to do anything with biologically. But we know that the number truly is, the true number is orders of magnitude greater than that. A pinch of soil, with 1 gram of soil, of forest soil, will contain as many as 4,000 or 5,000 species of bacteria, all of which are unknown to science. And the reason we haven't been able to do this is it's extremely technically difficult to culture and characterize bacteria by conventional biochemical methods. But now that we can determine a genome or a large part of the genome in a very short period of time, and that technology is developing faster and faster, we're going to be able to identify bacteria very rapidly. You're going to see this whole area of biology leap forward. In time, we should be able to take that pinch of soil and its 4,000 or 5,000 species of bacteria and read out the species in a matter of days, maybe less time. So that really will be a revolution. I wish I had time to dwell on the aspects of it. And then we go down to the gene level, and that is truly staggering. That's it's a photograph of the DNA of human cell, and the human DNA, which contains roughly 3.2 billion base pairs. That's to be distinguished from the gene, which each gene makes up somewhere in the order of 10,000 DNA pairs or letters. So you've been reading, no doubt, about Mr. Hasseltine versus much of the rest of the establishment about the number of genes. That's separate from the numbers of letters, which were determined in and read out for the most part of the human genome in this triumph of last year. So if you put all the DNA of a human cell, humans are fairly typical, and displayed them this way, you would require 2,500 of those panels. If you took the DNA from a single human cell. That is, the 4 long molecules or chromatids, and you put them end on end. Couldn't see them because they'd be only 2 billionths of a meter across. But you blew them up magically so that you could see them to about 2 millimeters across, about the width of a wrapping string. This is the human genome, 1 cell. And then you would have a string that would be approximately 1,820 miles long. And as you walked along it, you would read out about 100 base pairs every inch. That's how much genetic information. Well, of course, a lot of that we think is junk, but we're not even sure of that yet. But that's nevertheless reflects the enormous amount of information in a single species. So that whole area of the genetic diversity of species is now under rapid, our understanding is in rapid advancement. Where is biodiversity located? Everywhere there is liquid water and carbon and nitrogen source, from pole to pole, from the summit of Everest to the Challenger Deep at 36,000 feet below the Earth's surface. At the very least, there are bacteria and other microorganisms, some of which thrive in water above the boiling point and thermal vents on the seafloor, a species which actually cools off and cannot reproduce itself properly when water temperature drops to boiling. Also in supercool water, the Antarctic slurry ice, there are remarkable forms of fungi and bacteria 2 miles or more below Earth's surface, drawing energy from the metabolism of inorganic chemicals, so that if our species were so imprudent as to turn the Earth into a burnt cinder, there would be autonomous microorganisms 2 miles down that would carry on. And after a few billion years, I suspect oxygen would be restored and there would be, something like plants and animals back. So I just wanted to give you a little ray of hope in case something goes wrong. Most of the species of known organisms occur in the tropical rainforest, shown here in black, covering only about 6% of the Earth's land surface and down to about a half of what it was before humanity came along. We are in the process of exploring these rainforests, like this graduate student from Harvard in Borneo, with astonishing results and magnitudes of diversity and extremes of adaptation found there. The canopy in particular has just been penetrated with new techniques. This student is rappelling up, doing rope climbing techniques to get up and down, but there are other methods. This one developed by the Smithsonian to put in a building crane next to the forest, and then you can lower an investigator. That's one down at the end there, and if you're saying that looks pretty awfully dangerous, well, I'll have to tell you that's what graduate students are for. We haven't lost any yet. And then at the end but they don't just dangle there. They go in a gondola like this. The gondola can be shut, the door can be shut very fast because there are killer bees, the Africanized bees in the canopy, unfortunately. And so they can get out of danger quickly if they need to. Here you see them studying photosynthesis and the distinctive organisms that occur in the outer branches of the upper canopy where most of the photosynthesis and productivity of the rainforest occurs. That's where no one has ever gone before. You can't climb out there, and you need wings or something equivalent to get to it from the outside. Now, as everyone knows, the rainforest of the world, which contain, by consensus of experts working on biodiversity, terrestrial biodiversity, more than half of the species of plants and animals on Earth, is being eliminated quite rapidly by clear cutting, as this example in Brazil illustrates. And it is there where we are doing the most damage to the diversity of life. Here is a U.S. Air Force weather monitoring collage of the night sky above the Earth as it would be seen by an astronaut or a visitor from outer space. And you can see readily in the northern hemisphere, the Earth is well lit up. This land surface is well lit up with industrial activities of Europe and eastern North America especially. And then there's an incandescent Japan over there. You can see that. But what's interesting is the scattering of lights in the great rainforest wilderness areas of the Amazon and the Congo, and especially, and to the north of the Congolian rainforest, the Sahel region of grassland that covers so much of Africa. And those lights are fires of felled forest and grassland in progress. NASA estimates that we burn 5% of the Earth's surface every year. And through the years, without question, the great forest and other natural environments, particularly on the land, have been taken down at a horrendous rate. This is the state of Sao Paulo in Brazil, the black areas and forest. At first, at the time that Darwin was there, about 1830, after 1845, steadily reduced so it's less than 10% coverage in desperate condition. And here is a recent picture put together of the fate of the Philippine forest in the last 100 years. We start 100 years ago, 1900. The green, of course, is the forest in the Philippine Islands. Here we go, 1920, 1960, still not in in bad condition. When I say that the destruction of the natural environments and the loss of species is accelerating, I'm now about to show you what that means. 1960, 1970, 1987, most recent. I think I've got it. Philippine Islands are just one of the real basket cases of the natural environment. Now, this illustrates a principle well known and documented faunas and floras around the world hundreds of times by biologists, that as you reduce the area, you reduce the number of species that can be sustained there, natural species, plants or animals. This example may surprise you. Here are the national parks of the western United States and southwestern Canada. I've shown them, or the author here has shown them as islands, essentially. They are islands of natural environment in increasingly modified ranch land, suburban development, conversion to cropland, and so on. So instead of islands in the middle of a sea, they are islands in the middle of human-modified environment. And sure enough, as predicted, the numbers of species in them is dropping off spontaneously, even though, this is the case of mammals, even though they are well protected. What you're doing, you're coming down, the physicists call it relaxing. Sinister term. The number of equilibrial species, we assume is in equilibrium, sustainable and equilibrial, is dropping off to a new lower equilibrial level. That's over 100 years. This is the number of mammal species. And the larger the park, the fewer the losses. The smaller the park, the faster, and the more the losses. Now, the tropical rainforests are disappearing worldwide at a rate of 0.5% to 1% per year. The remaining cover of tropical rainforest is about equal to the coterminous 48 states. And the rate of destruction of the tropical rainforest, the world's treasure house of terrestrial biodiversity, the rate of destruction is about equal to half or all of the state of Florida every year. This loss of rate translates to 0.25% of the species extinguished or doomed to early extinction each year, or as we say, committed to early extinction. And then there are the alien species coming in faster and faster around the world, being spread by human commerce or deliberately. How fast are species going extinct? By three separate measures. First, the area species curve I just illustrated. Second, by tracking directly the change in status of individual species recorded especially in the IUCN Red Data List over a period of many years. And third, by increasingly sophisticated prognoses based on the current condition of endangered species in the environment. That's the method called population viability analysis. It has been estimated, and these measures converge within an order of magnitude or two. It's been estimated that the current rate of extinction is between 100 to 1,000 times higher than it was before the coming of humanity. Some believe that those brackets, and I'm one of them, that those brackets are too low, that the increase could really be on the order of 10,000 or more, because as entire ecosystems are eliminated, that is the whole thing, the last of the forest is cut, as in much of the Philippine Islands, the rate jumps dramatically upward. In fact, it goes from half, as I indicated, of viable species when 90% of the habitat is removed to upwards of 100% eliminated or due to early extinction when the other half, the other 10% of the environment is removed. Now, in sharp contrast, to anticipate a question I'm always asked, well, of course, the Darwinian process and evolution and so on is always adding new species, right? Well, the birth rate is actually dropping. That birth rate has always been, the baseline birth rate has always been only very roughly one species created per year per million species. And the extinction rate was always close to that too, but now it's been jumped upward 100 to 10,000 times. It's entirely possible, and some analysts say likely, that if present rates of habitat and destruction and spread of alien species continue, we could lose half the species of plants and animals on Earth by the end of the century. The story as worked out from the largest database, this is accumulated by the Natural Heritage Program over many years of the Nature Conservancy, shows that 1% presumed extinct of species of the United States. There are about 200,000 species of native plants and animals in the United States. 1% are extinct, but 30% are endangered, and many of those are, including some 8%, are critically endangered. That is, they're on the edge. Now, I've mentioned the bottleneck, and this, I think, is realistic, and it is also the hopeful way to look at the planet's natural resource problem, including biodiversity. It's a circumstance that we're now in, and in my opinion, the greatest challenge of this century, as it will be seen in future centuries, is how to raise the lives of people everywhere to a decent level while bringing through intact as much of the natural environment as possible through this bottleneck. The two goals are intertwined. They can be approached in a synergistic way in which progress in one enhances progress in the other. Scientists and conservationists now are focused on them together, and I mean on the two problems at the same time. I'll close with a dispatch from the Global Conservation Front to tell you a little bit about what is being planned and what is being done within the range of capacity of these NGOs and the private sector with the aid of government to staunch the hemorrhaging of ecosystems and species, and how at least part of the problem can be solved. First, it turns out that large blocks of the last remaining natural environments in wilderness areas can be preserved at surprisingly low cost, and in such a way as to yield greater profit to the countries owning them. It is simple as this. Logging companies, in some cases mining companies, but generally logging companies, are operating on a very thin profit margin. They can be outcompeted by conservation groups using private gifts, which are then leveraged by grants from other NGOs, such as the Global Environment Fund and the World Bank. For as little as $10 an acre, and often much less, conservation concessions can be established in which countries otherwise prepared to make logging concessions turn to preserve the forest instead. Or a trust fund can be set up the same way, with the proceeds being paid to the country for preserving and managing large reserves. Or the logging rights can be purchased, in some cases for as little as $1 an acre. Or finally, the land can be purchased outright. By these means, two organizations alone, just in the last several years, Conservation International and the Nature Conservancy, have already added over 2 million acres to the parks and reserves of Bolivia, Guyana, and Suriname, with the blessing of the administrations in these countries. They are also offering research and management expertise to promote the use of this land to yield a higher, and we hope higher and higher yield through time from tourism, carbon credits, and other non-invasive income sources that would be more profitable than timber leases in agricultural conversion. Other tropical developing countries around the world are now exploring similar arrangements. The World Wildlife Fund is working in another arena with the government of Brazil to set up large, new protected areas, some 80 new major reserves in the Amazon region. Another point of entry is the preservation of hotspots. Those particular forests, coral reefs, and other local habitats that are both endangered and contain the largest number of kinds of plants and animals found nowhere else. Just 25 of the terrestrial hotspots shown in this diagram cover only 1.4% of the land surface of Earth. That's about the same area as Texas and Alaska combined, contain an astonishing 44% of all known species of vascular plants and 36% of mammals, birds, reptiles, and amphibians. To preserve them, to focus and aim at them and preserve them, to take every measure to hold on to the environments in that, with reference to the whole world's land surface, relatively small amount of land, is the approach being taken by Conservation International, World Wildlife Fund, among the American-based NGOs. Not all hotspots are in remote forest, wilderness areas. Some are close at home. The Hawaiian rainforest, for example, the temperate rainforest of the Pacific Northwest, the California coastal sage shown here being obliterated, and the Lake Wales sand ridge of central Florida. These are the parts of the world in which resources have to be focused immediately and with some urgency if we are to save most of the diversity of life. So we have ways to save right away large swaths, if we move quickly, of the tropical wildernesses of the world, Amazon particularly, the Congolian forest, New Guinea. And we are focusing in on the hotspots of the land and soon on the shallow marine environment that will allow focused and, we hope, coordinated activity among the NGOs and government. It is clear that progress in global conservation is dependent on joint enterprises of the private sector, government, and science. We have to know exactly what is at stake, what needs most to be done, and how to do it, and develop a strategy of aid and development attractive to people everywhere and to their governments. Right now, it is the private sector working through the environmental, non-government organizations that form the spearhead of the global conservation effort. The largest of these organizations, including Conservation International, the Nature Conservancy, and the World Wildlife Fund in this country, have reached operating budgets in the $50 to $100 million level, and enough influence as organizations to form partnerships with the World Bank and United Nations, as well as work often with the CEOs of the largest corporations. They are backed by hundreds of smaller NGOs operating at levels from cities and countries to international venues. The NGOs are, in general, more entrepreneurial, more innovative, and more flexible than governments. But governments, at least those of the industrialized countries, still have to do the heavy lifting and will have to assume a larger role in the future. At the present time, about $6 billion a year is spent worldwide on conservation, proceeding from both private and government sources, most of it ultimately from government. A recent estimate suggests that roughly $26 billion annually is needed to sustain a sample of all the world's natural ecosystems and do something serious with a hotspot and let's throw a shield around a large part of the Earth's remaining biodiversity. If that seems a large price, 26 or so billion, to save nature and biodiversity, in other words, the creation, and to a large part our natural capital, keep in mind that it's only about 1 part in 1,000 or 0.1% of the combined gross domestic product of all the countries. 1 part in 1,000 to save the creation. The central problem of the new century, in my opinion, and to repeat, is how to raise the poor to an endurable quality of life, making it acceptable and secure for all of us, while preserving as much of the natural world as possible. Both the poor and biological diversity are concentrated in the developing countries. The solution to the problem will flow from the recognition that both depend on the other. Poor, the nearly 1 billion that are absolutely destitute, including and especially them, have little chance to improve their lives in a devastated environment. And conversely, the natural environments where most of biodiversity hangs on can't survive the press of land-hungry people who have nowhere else to go. I hope I've added today to the conviction shared by growing numbers of thoughtful people in all walks of life and of all political ideology that the problem can be solved. The resources to accomplish this goal exist. Those who control the resources have many reasons to achieve that goal, not least their own security. At the end of the day, however, the direction we take will be an ethical decision. A civilization able to envision God and an afterlife and to embark on the colonization of space will surely find the way to save the integrity of this magnificent planet and the life it harbors.
Thanks for joining us once again. As always, if you'd like to be in touch about future topics for lectures you would enjoy hearing, please reach out to bradleylecturespod@aei.org. For now, maybe take a moment to stop and smell the roses. And I hope you'll join us next time for the Bradley Lectures Podcast.